Okay. Any questions from the homework? Nick?
6.3, number 5, please.
6.3. Number 5. Dun, 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 dun. You have and rotated by x equal to and shell method. All right, so let's draw it. Eight minus 8. I plug in 1, I should get 0. So something like this. Okay, y equals 5 minus 5x. I plug in 1, I should get 0. So it's something like this. X equals 10. This region rotated by this. Okay, now you want to use a cylindrical shell method to solve this. Number 1, for cylindrical shell, you need to think about which way to cut. For this way, it's going to be a shell. For this way, it's going to be a washer. So we have to go with this. Okay, then you should go from 1 to 10. 2 pi RH. Your R and your H. So it's easy to see your R is going to be your X plus 8, and your H is going to be the parabola minus the straight line. So minus. Yeah, I would say your radius, it should be positive. You did negative, and also this should be plus 5x once you destroy the parentheses. So that's an algebraic mistake. This, you can think about it as this. Okay, you did the other way around. All right, Aaron?
6.2, number 1, please.
6.2. One. I think you got the right answer. You just forgot to square it. Pi r square, right? Okay. Other questions? All right. If no question, let's finish the last section, which is the average value of a function. Okay. Our goal is quite simple. We want to take a function. You can see sometimes it's 5, sometimes it's 10, sometimes it's 8, sometimes it's 7, on an interval from A to B. Okay. After that, I want to find the average value of this function. So you know the average value is going to be right in the middle, kind of, right? It's smaller than the biggest number. It's bigger than the smallest number. Okay, which way it's leaning more towards to depends on how many smaller number you have or how many more number do you have. So what you have here is you are looking for some number right in the middle. And this one, somehow we call it the average value of this function on this interval. So I better draw it on this interval. Okay, and the key you want to make sure is half of the number values are below and half the values are above. Sounds good? All right, so this is how we do it. How do we get the formula? Well, we start from the classic average value. Think about it. What do you mean by classic? What's the average value of 2 and 3? 2.5. How do you do it? 2 plus 3 divided by 2. Okay. What's the average value between 4, 6, and 8? 6. How do you do it? You technically take 4 plus 6 plus 8 divided by 3. Sounds good? What if I give you 10 number? What's the average value? Well, you just sum all the 10 number together, and when you finish, you divide by 10. Okay? So if I write down that idea, the idea seems like you just sum of the values. But then you raise a trouble because the more number you have, the bigger the value. Then you need to somehow normalize it or adjust it, because if you have one number and you have 10 number, you should really adjust the 10 number by dividing by 10. So everybody is on the same baseline. Okay, so you divide by number of values. Make sense so far? All right, so what do you have? What you have is something like this. Now, this time we're not talking about one number, two number, 20 number, or 200 number. We were talking about all the function values from A to B. How many numbers are there? Infinitely many, right? From 2 to 4, how many numbers are there? Infinitely many. Good so far? So you cannot take the sum anymore. What do? You take the integration. Okay, so F average is simply the sum of the values. Let's just sum them together. Sounds good? Second, each value is counted for once. So you should divide it by the total numbers of values out there. Each number got counted by once, from 2 to 4, from 3 to 5, an interval. You just sum the one together. Make sense so far? Okay, so finally, what is this? This is going to be that divided by b minus a. That's how we take the integration, right? We take the integration, which is x, we plug in b and a, that gives us b minus a for the bottom part. So this will be the average value formula. You sum all the numbers together, and then you normalize it to make sure that your number is big because your average value is high, not because you have a lot of more numbers. Okay. Let's try several examples. First one, the average value of sin x on 0 to pi. What do you think the average value will be? Zero, right? Part of it is above, part of it is below, and they're exactly the same. So if you take the average, it's going to be, they cancel out. It's 0. Okay. Now, by our formula, let's see, do we get the answer? B minus A. Okay, from A to B, sine x dx, which is 1 over 2 pi, cosine x negative 2 pi and 0. Can you see this is 0? Because cosine 0 and cosine 2 pi are the same. And then you take the minus. You are taking the same thing minus itself. Okay, so this is 0. That matches what we have. All right. Second, y equals x on 0, 1. Where do you think the average value is? Let's go to the old trick. What do? We draw something here to make sure the numbers above are exactly the same as the numbers below. Right? That's where the average value is. Anything above will equal to everything below. That's where the average is. Can you see that for this one? Since it's a triangle, the average value should be at 1/2 because they cancel each other exactly. Sounds good? All right, so let's do the calculation. F average equals what? Equals 1 minus 0 from 0 to 1 x dx, which is 1 times 1/2 x squared, 1, 0, which give you 1/2. Again, matches what we expected. Okay, the formula is really easy to calculate. So far, it makes sense. Now think about this case. Where is the average? Well, number one, it cannot be 1/2 anymore. Makes sense here? If it's a triangle, above, below, they're the same. They cannot be the same anymore. So this is 1/2, and it cannot be the answer. Can you see why? The one above, the one below. Can you see this one's too much? So in order to balance the both area, what should you do? You should move it down a little bit. Right? You should move it down to make sure the blue area equals the red area. So either way, the answer is going to be less than 1/2. I don't know what it is, but it's going to be less than 1/2. Now again, use the formula. Do we get what we want? And yes, we do have the answer. The answer is 1/3, which is less than 1/2, as we expected. All right. I think the formula is pretty easy to calculate. But do you see how to do the average value of the function now? That's exactly what we do. Okay. Now we need to go ahead and try to think about how do we understand this? It should make sense. We have several different ways to understand it. Okay. The first one is it comes from discrete value. Okay. Like we said, if you have the average value of these three, you simply just do that, right? Now, what is it really? What you have here is basically you're trying to do this. What you did is you take a rectangle, say this is 3. That's 3, right? Then you take a 4. And then you take a 5. No, 3, sorry. 4, 5. Now, what is 3 plus 4 plus 5? That will be the area of all the rectangles I just write down. Still okay? Why did you divide by 3? Because the width of the marshruti should not matter. Okay, so 3, what did you divide? You are dividing how many numbers are there. Basically, it's how big the interval is. Still okay? So can you see that this one can be written as this formula, like that? Integration from 0 to 3 dx fx, which is exactly the formula we have, except this fx is a piecewise defined function. Actually, it's a piecewise defined constant. Sounds good? So for discrete case, actually what do you have? You just have a special case of the continuous case where your function is going to be a special kind of function. But if your function is something else, my formula still can do it, but this way cannot do it anymore. Okay, so from now on, you can forget about the formula on the left because it's just a special case of the right. Are you surprised to see something like that? What if you have infinitely many numbers? What do? You just keep adding blocks, right? Set more number together, and then you divide by infinity because now the interval is infinitely long. Good so far? So what do? You actually do the reverse. You take this many thing and you try to squeeze it back into a finite interval. Okay? Then each length is not going to be 1 anymore. It's going to be very small. Do you realize this is nothing but Riemann sum when you squeeze all the rectangles into a finite interval? So of course it's related to integration. Beautiful. That's one way of understanding it. The second way of understanding it, this is what I'm trying to do. Okay. Then what I do is I take this f average, which is a number, I multiply b minus a. This is what the formula tells you. Right? All right. What is this? That's the area under the curve. What's this? I don't know what this is, but this is a rectangle. Why? Because f average is a number, b minus a is another number which you get from doing this. Okay. F average b minus a. So the left is nothing but the area of this rectangle. Make sense so far? So what is your f average value? That is exactly the same height. If I calculate the rectangle, it will be the same as the area under the function. That's what I'm looking for. Okay. Why? Why nothing makes sense? It's very easy to see. Why? Because you have some function like this. If I take the average value, what's going to happen? If I take the average value, what's going to happen is some part is going to be above the average, some part is going to be below the average, right? So what is exactly average means? That means the part above will be exactly the same as the part below. That's what you mean by average, right? That means all the blue areas should be the same as all the red areas. It's almost like taking everything above and fill them into the everything below to smooth out everything so you have a rectangle. It's like you chop off all the hills and put them in the valley. So now you have something plain. That's what average means. Make sense so far? So of course, if you chop everything which is higher, put them into the valley and find the area, it's the same as the original area. So that's the second meaning of average value, which totally makes sense. Number 3. Let's look at this formula. We know how to do integral. And we can write things in this way, right? So what do you mean? It means the average value of a function is the average changing rate of the antiderivative. Because this is the average changing rate of the antiderivative. Right? So think about the case. If I take small f to be the velocity, what is capital F, which is the antiderivative? Displacement. Right? So what does this formula tells you? It tells you the average speed equals the ending displacement minus the starting displacement, which is the total displacement, divided by the time interval. Right? Of course, that's the average. That's how we calculate the average for velocity before. Right? If you drove 100 miles within 2 hours, what's your average velocity? 50. Does it mean that you drive at 50? No, sometimes it's above 50, sometimes it's below 50. Right? But what's the average? 50. The ending minus starting divided by how long that interval is. So that's the third thing to think about of average. Of course it makes sense. Sounds good? So we have 3 different ways, and we can have more. Really, it depends on which perspective do you come from. You come from physics. This one can be viewed at the center of the mass with a uniform density. That's what your average is. Thought about it? Think about a bar. Okay, where is the center of mass? Well, here it's heavy, here it's light. You have different materials on this bar, right? What do? You sum all the weights together and then you divide it by how long the bar is. That's where your center is. If the left side is heavier, your center is going to be here. If the right side is heavier, the center will be here, somewhere. If it's uniform, your center will be right in the middle. Good so far. So from physics, you can get this one, okay, from the center of mass. From statistics, what's the average of the value? That's simply your mean value or expectation. Sounds good? Okay, if you learn stats, probably you won't see this. But if you have ever done statistics before, okay, finding the mean value of a distribution is nothing to find the center of mass. Think about that. Does it make sense? If I have all the people in our class, I want to say, hey, I want to use one number to represent the age of all you guys. Which number should I use? I should use your average age. Right? Similarly, if I have a lot of particles, this particle is here, this particle is here, this particle is here, this particle is here, this particle is here. But if I only use one number, one position to represent all the positions and the mass of all these particles, that point should be here, which is the average of all the particles. Okay, so everything is statistics. When you try to think about mean value, it's actually the average, which is actually the center of mass. Make sense here? Another thing that you need to think about, what does variance mean? Or what does the standard deviation mean? Okay, if you have a ball, the center is here. If you have a ball, center is at the same place but bigger. That's what your variance is trying to quantify, and think about what it means. We will not touch that in this class, but that's a very interesting thought process to have. All right, so that's the average value. It's just one formula, which totally makes sense. Now, what we have is the last thing, which is called the mean value theorem. Of integral. What does it say? It says there exists a such that FC equals C, actually C in AB. FC equals F average. All right. Let's think about what it means. If the function is like this, how do you draw the average value? Well, it's going to be below this. It's going to be above this. So somewhere in between, right? If I draw it in between, what does this one say? This one says, then somewhere your function should intersect with your average value, or it attains your average value somewhere at a C. Maybe multiple times, but at least once. That's what the theorem says. According to my graph, does it make sense? Why? Because you are the average value. Average value means what? You are below the highest, you are above the lowest. For sure. Meanwhile, my function is continuous. So I went from the lowest to the highest somewhere. So how did I go there? I cross the one in the middle. I have to, if I am continuous. Sounds good? Can you see this is nothing but the intermediate value theorem applied to this situation? So this is nothing but intermediate value theorem. All right. Very easy to understand. Okay. Second, is this the first time you see mean value theorem? Not really. You have another case, right? So let's write both down. This is what we have here, the integral version. It says FC equals this somewhere. Okay. Now, FC, you can make it, write it out. It equals something like this. It's the same thing, right? Do you remember the previous mean value theorem? What does it look like? It looks exactly the same, except you put this. This is the derivative version. Now, can you see they are talking about the same thing? Because f prime c is just fc. Sounds good? So what you have here is nothing new. It's actually something old, but represented in a totally different way. All right? So if you think about it, this is what we have for integral. This is what we have for the derivative. Somewhere your derivative should be the same as the average changing rate. Sounds good? Can you see that they're just doing the same thing, except one is doing it at this level, which is the changing rate level, and one is actually doing it at the capital F level. So these two are actually the same graph. Okay, except one is for F, one is for capital F. And according to what we just said, actually it's nothing but a variation of intermediate value theorem. So mean value theorem, derivative version, integral version, and the intermediate value theorem, they're actually the same theorem. You don't have to memorize them separately. Once you know one, you should know the other. Okay, so let's redo this. What do you mean by this? That means if you change from here to here, then somewhere you're changing faster, somewhere you're changing slower because you have the derivative. Sometimes it's faster than average, sometimes it's slower than average, right? Reflecting on this is you have the average slope. Sometimes you're below, slower, sometimes you're faster. But this time I'm talking about the derivatives. Okay, so they're talking about the same thing. All right. Some extensions. What does this mean value theorem mean? That means if you have something which is continuous, let's say this is a sphere, okay, then the center of mass is in this sphere. That is, there exists a C such that Fc equals to F average. Therefore, the center of mass is in this sphere, which is kind of like a, I don't know, waste of time, right? Of course it's in. Okay, but now think about this case. This time we don't take something continuous. We take something discrete. Where is the center of mass? Here. Is it in the original sample? Not really. This is something you created. Makes sense here? This does not belong to anybody. It's not in the original set. So the mean value theorem fails. There's no FC such that FC equals F average. Why? Because FC can only be here, here, or here. Right? But your average is not one of them. Good so far? Okay. Why is that? That must be because this function is not continuous. You only have 3 points. You jumped from here to here, there to there. Then, of course, you do not attain your average value. Okay, so that's basically what mean value theorem gives you. All right. That'll be all for today. Any question regarding what we have here? If no, that's all for the whole semester. Okay, we stop here. And the whole class is over. Now let's briefly talk about our plan for next week. Okay, from today,